Hello, everyone. Thank you for the opportunity to give this talk. I'm Graham. I'm a second year PhD student at the University of Nottingham. I'm going to be talking about parallel monitoring, so running existing traditional approaches alongside novel machine learning or AI-based approaches, and using that for pollinator monitoring and looking at the impact of specifically of using rewilding as a case study for my work. And so I've just done a little bit of a definition of what I mean by parallel monitoring here. So there's sort of three ways that I'm framing it, which is if you're doing traditional sampling where you're taking the data that you already have and running the models on that. So you've got all of your IDs already and you're comparing them with the IDs you're getting as an output afterwards. Or you can run traditional field-based sampling methods alongside a sort of analog. So in this case, the analog, which is I'm going to get to, is what I'm trying to do with my work, is running a pan trap analog that's as close to a pan trap as possible. Or you can just augment existing sampling method by sticking a camera directly onto it. So in that case, like Quentin's sticky pie is quite a good example where you're just taking a existing sticky trap and you're putting a camera straight in front of it and processing it that way. So why would we bother doing this? So this is a bit of a death by text, but the rest isn't. So it enhances compatibility with existing schemes. So basically, this allows us to sort of calibrate as well the performance of our traps. If we've not got any traditional monitoring that's going alongside it, how do we know that it's doing a good enough job of picking up the species we want to, or if it's missing certain species because of the resolutions we're using, etc. And it also acts as a bit of a fail-safe measure in the early phases of the work we're doing. So if you do have your AI sampling fail or your traps fail, having the traditional monitoring to start with is quite a good idea, I think. And there is a sort of danger of us going hard into it and not having that as a fail-safe at the beginning stage. Problems with the AI-based traps is obviously insects revisit, so it's not the same as traditional monitoring. You get duplication, and you might end up interfering with behavior if you introduce cameras, create shadows, etc. And it might restrict our creativity if we have to try and meet the need of matching traditional sampling in any way. So sticking a camera on something that's already doing a good job but might not be ideal for imaging is a problem. So, and it reintroduces extra labor at the early phases, which we're all trying to eliminate and try and do a good job of actually making our life easier rather than harder again. So these are some of the existing pollinator monitoring methods that obviously we can use. And what I'm going to talk about is a few examples of ways we can run pretty parallel methods alongside them. Obviously, pollinators are undergoing widespread decline globally. And so monitoring them through all these different methods for different target groups is quite critical for informing appropriate and specific action at your relevant site. So with rewilding, this is quite important because we don't know the impacts rewilding is having, which is my case study. Here I've just sort of divided them into the passive, where you can add attractants in. So pan traps can be fluorescently coloured, or they can be quite plainly coloured, but usually you do add an attractant element into some of these, but you don't really have a choice with light-based moth traps and pheromones and resource traps like nesting traps for solitary bees. And one big gap is active sampling, which I'm going to come to. We don't really integrate AI a lot into sort of structured active sampling at the minute. So I'm trying to have a play with that as part of the work I'm doing. Here's some existing possible parallel approaches and ways they're not quite parallel at the minute. Diopsis and insect detect, the current setups are kind of quite close to being pan traps in a way. They're different shapes in terms of their sort of their backgrounds that they're using. And the FAIR device, there was it Edgar that mentioned earlier about using the sort of Malaise-based device where insects were coming through. There's another one here is the FAIR device. This is fantastic, but there's currently no validation against like the actual specimens coming out of the Malaise trap because there's no lethal thing, which is great, but we don't know what we're missing. So yeah, and that's some other examples there. But I'll just get on to some of the parallel candidates I'm using and where I'm using them. So I'm working at a rewilding site, which is quite a good candidate for using these AI approaches and because it's already scalable low-cost approach for conservation management. So if we can use low-cost scalable technology alongside rewilding, we're getting the best out of both worlds, but we don't really know how good it is for pollinating insects. And we have some things that are opposing. So it often bare ground decreases over time at rewilding sites, but in early stages, floral availability is increasing. So ground nesting resources and basking spots for a lot of species are changing quite significantly, and we don't know the impacts on the community at rewilding sites. So here's here's my setup. So I am working with pan traps, traditional pan traps, and taking photos and scans of the insects coming out of it to do the point A, where I'm looking at the traditional monitoring and just taking identical things outside of the field. But I'm also I've adapted Max Sittinger's insect detect to try and create identically sized rings for a pan trap to run in parallel to my existing pan traps to compare directly with the results to sort of validate these approaches. And then another thing, which is a little hardware demo, it's probably the tiniest, most underwhelming part of the hardware demo. But it's just a little pot that I've been developing, which is a little standardized image pot for active sampling. You can take out in the field with you, presses insects against the top lid and immobilizes them without damage to create an opportunity for doing systematic sampling through transects in the field. And yeah, then putting that through a pipeline, for example, with ops identify to get results. Okay, that's me. Thank you.
Thank you.